Hi guys, we're back here with our Redline PID controller, and what we're going to do is we are going to introduce an integral in this video. And so first thing we want to do is go back, and to show you how integral's doing this, I'm just going to move the proportional band back to 100%, and I am going to, which is a gain of 1, and I'm going to go ahead and set the integral time at 1 minute per repeat. And so I'm going to prove to you here that integral actually repeats what proportional does. So we're going to introduce a 10% error, and then you're going to watch proportional hammer that output right away by 10%. And then during the next minute, integral is going to repeat what proportional does. And at the end of 1 minute of time, you'll see that the output is actually moved an additional 10%. And the next minute, it moves another 10%. So let's go take a look at the Crimson software here, and if I can get this thing to come in focus here. There you go. You can see the proportional band is set at 18, and that's 18 inches, which is actually the span of our range. We go from 6 to 24 inches. So it says it takes an 18-inch change in level to make a 100% change in output. That puts it at a 1-to-1 ratio, which is the proportional band of 100%, or a gain of 1. Now you see the integral time here is 60. I said 1 minute per repeat. Well, you got an integral here in seconds. So 60 seconds is 1 minute. So at the end of the day here, we have got a gain of 1 and an integral setting of 1 minute per repeat. Now what I'm going to do here is I'm going to come back over here. I'm going to go ahead and set a stopwatch and my cell phone, and I'm going to let that thing run. So as soon as I make that 10% error here on the input, we're going to watch and see what happens to the output, and then we're going to watch the timer too. So I'm going to bump this up to 13.6, which will be a 10% error, and we will quick check those things. Okay, you can see that we moved down to 10.4, and my timer is running here. Okay, my lap timer, and you can see that it's moving away from where it was. That's integral. Integral is working on the output right now. It's producing another 10% over the next minute. So anticipate that if this goes down 10% over a minute, we will have gone from 10.4 down another 1.6, so we should end up at 8.8 milliamps after 1 minute. Okay, so when we hit 8.8 here, I'm going to flash down at the timer, and I started the timer a few seconds late, so we might not be exactly at a full minute, but we're going to be pretty close. So we'll see here, we're at 8.8. Okay, so 8.8, and I'm at 53 seconds. Okay, let's let this thing run another minute. And you can see we still got the same 10% error. We still have a gain of 1. And the integral again is repeating proportional one more time in the next minute. So from 8.8, we're going to go down another 1.6 milliamps, another 10% in the next minute. So 8.8 minus 1.6 is going to put us down at 7.2 milliamps, right? So we should be at 7.2 milliamps when we hit 2 minutes. Let's see if I can get them both in here at the same time. Yeah. So you can see we're at a minute 39, 40. You know, we'll see where we're at when we hit 7.2. And remember, I started it just a hair late in the beginning, so there we are. So we're still just at 10 seconds off. So it moved exactly another 10% in the next minute. So that's integral repeating proportional at 1 repeat per minute. All right, we're going to end that video there. Even though we could change and go with a different rate setting, it's still all going to work the same.